We live in the best of times. We live in the most critical of times. I may be Paul Stamets standing here, but in fact I'm a collection of microorganisms unified with one voice, speaking to you and your collections of microorganisms. We have come to a point in the evolution of life on this planet that we need a collection of individuals to create the threshold necessary to have a paradigm shift. Whether Nina and Kenny realize it or not, they have pioneered a new superorganism, us, and it is our collective wisdom and respect of nature that I think that we can make that difference. I'm going to be talking about 5 different species complexes, and I'm truly honored to be here in this lifetime because I think that individuals and us as collections of individuals can make that difference. So I spend a lot of time in the old-growth forest, and this is something I have a deep debt of gratitude. And in the old-growth forest, many people may not realize that it's the best storage of above-ground carbon on the planet. And protection of the old-growth forest will do a lot to protect this planet from climate change. Whoops, can you go back, Eric? So these are my 4 people that most influenced me in my life. This is Dr. Alexander Smith, this is Dr. Daniel Stuntz, Dr. Michael Bugh, and Kit Skates. And it's all the more remarkable that they sponsored my research when I was around 19 or 20 years of age, because this is what I look like. You can draw your own conclusions. So I have had several epiphanies, and I tried to focus, my words very carefully, and this really rings true to me. As habitats and humans share immune systems, and mushroom mycelia are cellular bridges between the two. So when you go into the old-growth forest, you see standing trees and you see dead trees, but those trees are not so dead. They are life springs for all sorts of communities of other organisms. And when the trees are cut, of course, deforestation, massive erosion. A lot of people don't realize that the forest is cut and logging roads are put in. It interferes with the hydrology and the passing of water going downhill. So the erosion, siltation is a tremendous threat to the other organisms, of course, that live in this ecosystem. So most plants associate with fungi. And most of you know about mycorrhizal fungi, and the mycorrhizal fungi and actually the roots, and the mycelium that sheathes the roots can actually surface. The mycelium exhales carbon dioxide, inhales oxygen. The mycelium, when it's triggered under certain weather conditions, is capable of producing mushrooms, but oftentimes the mycelium remains resident for decades, even hundreds of years before a mushroom will show. And the mycelial network is a lattice work of fine fibrils, and these filaments are extremely well netted. And so the mycelium is a microfiltration membrane in and of itself. Also creates microcavities that absorb water and sets up the stage for other microorganisms. And so looking at the mycelium, and under the electron microscope, I was always fascinated with how well articulated it was. Well, the mycelium does so much more than just digest nutrients outside of its cell walls. It's in constant biomolecular communication with its ecosystem. And this really becomes quite apparent when you look at the mycelium as it transfers nuclei. These are a series of microscopic movies by my friend Patrick Hickey. And before his work, we did not know that there are hundreds of nuclei that run through the mycelial nets. And at the end tips of the mycelium, in literally a meter diameter patch of mycelium, can be trillions and trillions of tips that are always experimenting, always sorting. And if there is a successful recombination of DNA that allows a new enzyme, a new antibiotic, a new way of gobbling up a food source, what happens? The information backstreams through the entire net, the net becomes educated. So I believe that these indeed are neurological networks. These are thinking membranes. They're literally sensing you with every footstep that you take. And in the aftermath of your footsteps, the mycelium reaches forward to try to gobble up the new nutrients. But they do so much more than that. They set the stage for the plurality of organisms that allow ecosystems to be diversified, and in doing so, a plurality of cooperating organisms create habitats that support us. The loss of biodiversity is a direct threat to that sustainability. And so people can say, well, is it true that these cellular networks can actually are intelligent? And I draw your attention to this recent experiment on the slime mold. And this was done by some Japanese researchers. And this center flake of oats represents Tokyo, and these are all the sub-cities around Tokyo. And so the slime mold was inoculated into what is Tokyo after 0 hours, then after 5 hours it grows out randomly after 11 hours, but then after 26 hours it shuts down all the non-essential pathways and redesigned the Tokyo subway system in a more efficient way than is designed today. And moreover, when mathematical analysis was applied, they found something astonishing. The mycelium, given these different options, optimized mathematically, making the best possible design that engineers could come up with. So if you have an engineering hurdle, maybe you should ask a slime mold. So, and this is one of our slime molds, Fuligo cristata. We have this running around our property. It shows up every few years and it says hello and then disappears again. But truly, these things are running literally underneath your feet, all around you. And so I postulated that the mycelium is Earth's natural internet. It's a web-based life form. And these web-based life forms are able to adapt and evolve very, very quickly. And they adapt to catastrophia in a way that I think is quite important. And so you can take, for instance, an expired oyster mushroom kit that you can buy from lots of companies, and after it stops producing mushrooms, there's not enough nutrition there for the mycelium to build a new mushroom. Well, you can take crankcase oil from your car, pour it onto an expired oyster mushroom kit, and then 2 weeks later, you have mushrooms popping up. The mushroom mycelium is able to break down hydrocarbons and remanufacture them into fungal carbohydrates. And this ability of being able to detoxify these complex hydrocarbons makes mushrooms and mushroom mycelium extremely applicable for breaking down a wide variety of hydrocarbon-based contaminants. So after the BP oil spill, lots of people wrote me saying, Paul, what would you do? So I started doing some experiments, and I was really interested in using oyster mushroom mycelium into making it into booms. And so I created mycobooms that float on water that would excrete these digestive enzymes that will start the process of breaking down the hydrocarbons. And then I went further, and so I wonder if it would survive in a saltwater environment. And I have a workshop this afternoon. I'll go into this in greater detail. And sure enough, the mushroom mycelium does very well in a saltwater environment. And something astonishing happened. When the mushrooms were in these aquatic environments, fresh or saltwater, the mushrooms would form. They would attract flies. Well, then all sorts of fish and in the ponds, frogs, then would pre-position them right beside the mushrooms. And then that ended up being a food chain that helped the ecosystem and its members that are otherwise threatened by toxic waste. So the idea of using mycobooms and hemp socks as a biodegradable way of controlling oil and starting the process of decomposition, I think is something that should be further studied. And then after Fukushima, I had several hundred people write me saying, Paul, what would you do? And so I came up with the nuclear forest recovery zone. And there's a mushroom here that was discovered after Chernobyl that hyperaccumulates cesium-137, more than 10,000 times the background levels of radiation. And the mycelium upchannels the heavy metal, concentrates it into a mushroom. Now, why would it do that? And well, that's very interesting. We may not know why, but we do know the consequence of that activity protects the plurality of the other organisms resident in the ecosystem. The mushroom becomes highly radioactive. And ostensibly, you could go in and harvest a mushroom and reduce the cesium levels in the ecosystem using the mothering mycelium to upchannel and concentrate those toxins. So I propose around Fukushima that they create a nuclear forest, an old-growth forest. How long will this take? It's not going to take weeks or months in this case. It's going to probably take decades, even hundreds of years. Many of you may not know that now they found outside 35 miles around Fukushima, 30 times the allowable limits of cesium. This problem is not going to go away for a long time. But I think nature ultimately will repair itself, but may not be the case within the context of our own lifetime, but in the context of generations to come. We need to think way into the future about the implications. So when I go into the old-growth forest, Eric is advancing the slides for me back there. And so we go in and this is the forest that I hope that we would see around Fukushima, maybe in a few hundred years. But the nuclear forest, I think, it become a teaching lesson, a park for future generations. So one of the other mushrooms that we focused a lot of attention on is called agarikon, Fomitopsis officinalis. First described by Dioscorides in 65 AD as elixirium ad longum vitam, the elixir of long life. This mushroom has revealed to us an enormous repertoire of novel antivirals and antibacterial medicines that can be extremely important today. And in fact, we have discovered now within this mushroom a new class of medicines. And this mushroom grows exclusively in the old-growth forest. It's now thought to be largely extinct in Europe. It grows in Northern California, Washington, Oregon, and British Columbia. And to give you an idea, here's some people here, and they're approaching one of these old-growth trees, and there it is. And this is the longest living mushroom in the world. Now think of that. This mushroom grows in the old-growth forest and does not rot. It grows for up to 100 years in its lifespan. How does it do that? How does it survive under those adverse conditions? Because it has a host defensive immunity against bacteria and viruses and other fungi that we can tap into. So we have spent an enormous amount of research over the years and money working with a group of other talented people within my company. And so we have our agarikon team. We go out into the old-growth forest trying to find this species. And this is the largest one that we've been able to find so far. Scott Baker, a friend of mine, uses his hacky sack and the fishing line. He then sends up a guideline, and then he goes up the tree. And he ascends this 700-year-old Douglas fir tree up in Canada. And that is the oldest and longest living agarikon, i.e. the mushroom in the world known today. We were able to get this into culture. We don't pick the mushroom. We use these little cork borers, and we get a small amount of tissue, this much, and then we put it into culture and in our laboratories, and then we test these strains. To date, we have 40 strains of agarikon, the largest strain library of this rare species in the world. My dear professor, last week, after hunting mushrooms for 40 years, found his first agarikon. That's how rare this species is. This mushroom is calling to us. We have a propensity for being able to find it now. And it's really important that we protect the mycodiversity of the species because of its inherited talents. And so we have been looking at the extracellular metabolites coming from this mushroom. And we have now identified a new class of medicines, which I'm calling fomitopsterols, named after Fomitopsis officinalis, the Latin name for agarikon. This is extraordinarily exciting. We've been working with the University of Mississippi School of Pharmacy. And the fomitopsterols, when diluted to 1%, are more powerful than the best antiviral drugs currently on the market, including ribavirin, that's used against flu viruses. We have found super activity against herpes simplex 1, against pox, and extraordinarily high activity against bird flu. So we think we have a really good argument that I've stated before, but it reinforces this argument that we should save the old-growth forest as a matter of national defense. So mushrooms are great sources of vitamin D. We can give 8 hours of sun exposure to mushrooms and produce over 46,000 IUs of vitamin D. With UV light, we can go up to 267,000 units of vitamin D per 100 grams. But another mushroom that is interesting, it attracts insects, but it's something that has been the focus of traditional use for more than 2,000 years are turkey tail mushrooms, a long history of use in Asia and Europe. About 7 years ago, we were funded by the National Institutes of Health for a breast cancer clinical study. I actually was a co-investigator, and then when the money was approved, the other researchers asked where we should get their mushrooms. I said, where did you get them from us? They said, no, there's a conflict of interest. You can't be a co-investigator and a supplier. So we became a supplier. And this study is now being completed with what's called with breast cancer patients that are estrogen responsive negative HER2 positive breast cancer patients. Dr. Leanna Standish first presented this data at the New York Academy of Medicine. Prior to radiation, this is your baseline of your natural killer cells, and then after radiation, your natural killer cells plummet. And then in a dose-response basis of 3 grams and 6 grams per day, your immune system rebounds dose-dependently. The more of the turkey tail that you take, the greater the rise in your natural killer cells. It does not overstimulate the natural killer cells. This became really important to me personally in June of 2009 when my mother calls me up and she says, Paul, I have something to talk to you about, but you're always so busy. It's a terrible thing to hear from a mom. I said, Mom, what's wrong? And she started crying and she said, my right breast is 5 times the size of my left. I have 6 angry lymph nodes. I'm worried. My mother had not seen a doctor since 1968. I immediately took her to the Seattle Breast Cancer Clinic at Swedish Hospital and spent most of June going to clinics. Upon the second visit, we got the bad news. Her tumor was 5.5 centimeters in diameter. It metastasized across the meridian. It went into her liver and into her sternum. The doctor said this is the second worst case of breast cancer they've seen in 20 years of practice, and she should have been treated 2 years earlier. And, you know, we had the circle meeting. I got appointed as the executor of the estate, and my mother planned for her own funeral. On the second visit, but the doctor said there's an interesting clinical study going on with turkey tail mushrooms. You might want to consider taking those. That's when my mother said, my son's supplying those. Now, my mother could not have a radiation therapy or a mastectomy. She was 84 years of age at that time. Well, I'm very happy to report that my mother now has no sign of any tumors whatsoever. I got my mom back. Some mushrooms depress the immune system. These are cordyceps mushrooms. They're entomopathogenic fungi. Many of you have heard of cyclosporin. That's used to prevent organ rejection. Well, a new immunosuppressant drug called Gilenya has been just approved by the FDA, and it's coming from another cordyceps mushroom. These infect insects and override their immune system. And Novartis predicts that this could be one of the top six most profitable drugs sold or even invented in the world of medicine. So I'm real interested in insects, and I chose, because my carpenter ants were consuming my house, I started looking at these fungi, and they have two faces. The cordyceps has a mushroom state, and it's got this mold state. And hundreds of other researchers worked on this for years for the biopesticide industry to solve the problem of termites and carpenter ants destroying your house. But the insects aren't stupid. They're repelled by the spores. And so when I saw these little white growths, I thought, that's interesting. And so I chased these little white growths called sectors. And what I was able to do in a matter of a few weeks, I was able to morph the mycelium from this state to this state. Now the insects no longer were repelled by the spores, and I discovered something huge, absolutely huge. That the insects that would otherwise be repelled by these infectious spores are attracted to the mycelium. And so I started doing lots of research, and I found that they became super attractants. Swarming behavior occurs. And so I started doing more and more work with this, and the mycelium mummifies the insects, and then, under certain conditions, a cordyceps mushroom pops out. So it goes full circle. I'm very happy and honored to have worked on this now with a great group of colleagues at my company, and we started making extracts of the mycelium, and we can steer termites. This is 3 different positive controls, 1 treatment, and the termites go specifically where the extracts have been placed. And then I started playing around with fungus gnats. Now, this is a remarkable slide because this is the positive control, which is water, alcohol, and sterilized rice. Same thing, but the mycelium's been added. And the attractancy of fungus gnats was actually remarkable. So I tried it with social insects, ants and termites, and fire ants, and lots of other social insects. And this does not harm bees at all, which is very, very cool. And so then I tried it with non-social insects, gnats. And then I tried it this past year with mosquitoes. And I talked to Bill Gates, and I said, Bill, if I could concentrate mosquitoes to a single locus, that would help us control malaria. Are you interested? And he goes, yes. So a year later, I came back and I showed Bill this graph. And we are able now to attract mosquitoes roughly similar to that of a human hand. Let's put it into a cloud chamber with about 100 mosquitoes that land on the hand within 5 minutes. And now our living mycelium of this entomopathogenic fungus that you saw before attracts those mosquitoes. That's huge because mosquitoes carry lots of diseases and pathogens. And so going forward, how many diseases do insects and arthropods vector? Enormous number of diseases are transferred by insects to plants and to animals, weaving animals to us. And so I was working on this diligently, and then I realized, oh my gosh, we have a potential here of controlling zoonotic diseases coming out of ecosystems in an ecologically rational way, not using chemical pesticides. And moreover, I don't have to kill the insects. All I have to do is attract them, and I can reduce their pathogenic payloads. So the ability now of being able to steer insect migrations across landscapes, protecting the general immunity of human populations, combining that with turkey tails to boost innate immunity, and then stopping the vectors that bring in these diseases, this is a paradigm-shifting breakthrough. So I received 4 patents on this, actually 5, 1 in Australia. And my last 2 patents approved this year, May 31st, the U.S. Patent Office gave me essentially all entomopathogenic fungi against insects without restriction to species. That's 1 to 2 million species of insects. Now, we were very reluctant to give a patent like this because these are such a big, scope in terms of their implications. Now, some people are sensitive about patents. They reward the inventor initially, and then 20 years they go into public domain. But I respond, I treat this knowledge very sacredly. It's very important. It's a huge responsibility. And it's better for me to have it than Monsanto. So what does this all mean? This means that we can make toxic chemical pesticides obsolete. These fungi exist literally under every footstep you take on the ground. These fungi exist literally wherever there's an ant colony or a termite colony, there's a graveyard, and these fungi are indigenous to that graveyard. We can amplify native species in any bioregion of the world. I've done this now with about 20 different insects and applications, and every test that we're trying has been working. We had a recent event where we had a swarm of moisture ants in a room, and we put down a little bit of this extract with a control, and you have to see it to believe it. To see a swarm of insects in a room, all then hyper-concentrate right where the extract is. This, I believe, will save billions of dollars, millions of lives, and protect microdiversity. I'm here today because of the generosity and kindness of Kenny and Nina and all of you. I treasure my position and role in life. Life is too short. It is not what we do in our lifetime, it's the legacy that we leave. And we need to make sure that our descendants can look back from the future and know that we tried to do the right thing. I want to thank you all very much.